Savannah. I'm from Shawnee, Kansas, and my research addresses the impact of long-term microgravity on the female reproductive system in mice. And so microgravity, as defined by NASA, means zero gravity. Now we know that microgravity has major physiological impacts on our astronauts. We know that it not only causes muscle loss and it causes decreased bone density, but it also causes rapid fluid shifts inside the body. And while we have a lot of research on how microgravity impacts our astronauts' bones and muscles, we have hardly any research on how microgravity impacts our astronauts' reproductive health. Now this is especially concerning because our current astronaut class is 60% women, and we have no research on how microgravity impacts our female astronauts' reproductive health, which is exactly why I'm doing research on it. But first, let me give you a little bit of background. So we sent 40 female mice up into space on the ISS. Within that group, 20 mice were on the ISS for 41 days before they were brought back down. This is going to be our LAR flight mice, and I'll get back to these guys in a second. But for right now, we're going to focus on our ISS flight mice. So the remaining 20 mice were on the ISS for an additional 18 days for 60 days total. So our ISS flight mice were on the ISS for 60 days total. Now at the same time that these guys were on the ISS, we had two control groups here on Earth. So we had our habitat ground control mice and our vivarium ground control mice. And both of these mice were kept inside something called the ISS environmental simulator. Now what this does is that it replicates what it's like being up here, or what it's like to being up on the ISS. So it has the exact same temperature, humidity, light exposure, and our HGC mice were actually kept inside the exact same cage as our flight mice. So the only variable between the two was microgravity. Our VGC mice were kept inside a regular cage at regular temperatures. Now, after all these mice were euthanized and their tissues were collected, I then took these tissues and I did something called histological analysis. Now, this is where you take the tissues, you dissect off all the extra fat, you embed it in something called paraffin, and then you microtome them into really, really thin sections. I stain them using something called hemotoxin and eosin. I imaged it using a microscope, and then I ran digital analysis using ImageJ. Now from here, your tissues are gonna end up looking something like this. So then I took ImageJ and I measured all these different sections, and I found that our ISS flight mice had a significantly decreased size of their uterus compared to our two controls. I found that it not only decreased the size of their uterus, but microgravity decreased the size of their uterus, but I found that microgravity also decreased the number of something called uterine glands. Now, uterine glands are crucial for pregnancy. They're crucial for providing the uterus the nutrition that it needs. It's crucial for providing the embryonic fluid. And so I found that our ISS flight mice had a significantly decreased amount of uterine glands compared to our controls. Now, as I was saying, those were just our ISS flight mice. We also have more mice. So, going back to our LAR flight mice, these mice were up on the ISS for 42 days and then brought back down to Earth and allowed to recover for 5 days. After 5 days, 4 of these mice were euthanized. And you would think because we saw such a dramatic result with our ISS flight mice that we would see the same thing with our LAR flight mice, but actually, I didn't see any impact at all. Our LAR flight mice were indistinguishable physically compared to our controls. So, microgravity is impacting the size of our uterus. However, once the mice are back on Earth and allowed to recover, their uterus fully recovers its size. But what is really even more interesting about this is that our remaining 16 LAR flight mice were taken and they were bred to a regular male mouse, along with all our 2 other control groups. And I found that the offspring from our LAR flight mice compared to our control mice were very different. I found that they had very wild behavioral issues. They had metabolic issues. They had decreased size of their muscles inside their thighs. So even though our LAR flight mice seem to physically recover in their uterus, there's something molecularly that microgravity is doing to these mice that is changing their offspring and is changing their reproduction. So for the future of this experiment, I'll be doing blood tests on all these mice because we were able to collect their blood before they euthanized them, and I'll be seeing whether or not estrogen has anything to do with it. Thank you so much.
Wow. Oh my gosh, that's really, and it's just the sort of thing that you would have thought, well maybe you wouldn't have because you know how things work, that this would be something they would have looked at right away, especially when we're
Exactly.
talking about doing colonies in space and things like that. And yet,
Exactly, because I've done like a lot of research, and so I looked at like the NASA twin study, and so they looked at so many things that happened to the astronaut that went up into space compared to his brother. Like they did testing 6 months prior, they did testing during, and then they did testing 6 months after, and then a year after, and they found that the brother that had gone up into space had shortened telomere length. They
yeah,
looked at his retinas, and it had like decreased back into his head. They looked at his height, which had increased, and they looked at like a lot of things in his body that had changed due to microgravity. And yet, like even though they ran all those experiments and all those tests, and we've made it thus far to realize that microgravity has such a big impact, there's so much that's still unknown about how microgravity impacts us in the
because
long
neither of
term.
the twins had uteruses.
Exactly. So we weren't able to look at that, but maybe in the future.
Okay, great. All right, thanks so much.
Thank you. It was great to meet you.
Yeah.